Hi, my name is Irmak Bukey, and I'm here to present to you our work on generating sheet music images. In this research, our goal was to explore and evaluate various approaches to generating sheet music images. For generating these images, we employ a setup where we pass in a seed into our sheet music generator, which is a language model in our case, and it produces its continuation in sheet music form. So why do we want to generate sheet music? Well, first because it's the primary form for musical composition in many genres, and it contains important information not found in MIDI or audio, such as time signature, key signature, measure boundaries, and inharmonic information. Additionally, it allows us to solely focus on composition rather than low-level performance details like individual note velocities, and allows us to take advantage of the abundance of sheet music data out there. In this work, we use the Primus dataset, which includes more than 80,000 sheet music excerpts and several different encodings of sheet music, such as PNG format, a semantic encoding, and an XML format. And the semantic encoding is a symbolic encoding that describes musical symbols in sheet music. Using these formats, we experiment with several different ways of generating sheet music images, which fall into two general approaches. Our first approach is to generate PNG images directly. We do this in three ways. One is the pixel columns, where we divide the images into columns that are 1 pixel wide. Second is the image patches, similar to pixel columns, where instead of columns, we have n by n square image patches. And third is the visual tokens, where we identify tokens by separating on empty staff line pixel columns. For each of these, we then binarize the pixel values and convert each partition into a discrete word, and we train our language models on these word sequences. We use two language models in this paper, AWD-LSTM and GPT-2, and here after training we have the model spit out continuations of the seed that is passed in. Our second approach is generating visual encodings, where we train on the semantic encoding and XML code representations. We are then able to render the output of our model to display an image for us to evaluate. Looking at our results, we see that for image-based tokens, there are some visual artifacts, such as this image patch here not looking clean. We also see that they don't obey stylistic conventions, like the incorrect grouping of eighth notes here, or the 3/4 rests instead of a whole rest in this bar. Another observation is that they are metrically incoherent, meaning most of the time we don't have the correct number of beats per measure. Looking at the visual encodings produced, we do see that they are visually more coherent due to us rendering the encodings in a systematic way, and overall there are more measures with the correct number of beats in them. However, metrical coherence is still a problem in many cases. To study this problem further, we conduct a quantitative analysis of metrical coherence. Here we measure the metrical coherence of each model for each time signature, and metrical coherence is defined as the percentage of measures with the correct number of beats. The figure on the left compares metrical coherence between AWD-LSTM and GPT-2 when generating semantic tokens, and we see that the two models perform similarly for semantic token sequences. The figure on the right compares metrical coherence when generating XML code, and GPT-2 actually outperforms the LSTM when generating XML. We also observe that both models perform poorly on rare time signatures in the dataset, like the 5/4 and the 7/4 time signatures. In summary, symbolic representations compared to image-based approaches yield more semantically coherent sheet music, but this is not to say that the results are perfect, since we still identify metrical coherence to be the biggest problem that needs to be addressed in future work, and we see modifying language models to obey the metrical rules of music as the most promising direction. Thank you.